Let me introduce the next speaker, Rahat Yasir. He is data and AI platform architect. His topic for today is enterprise data and AI strategy and platform design. Rahat, are you ready? Please come on.
Can you see my screen?
Yes.
Perfect. Thank you so much. Yeah, thank you for organizing such a great data science camp. And from my side, as you have already said, enterprise, like my topic for today's conversation or presentation is enterprise data and AI strategy and platform designing. So a lot of times what happened when we talk about data and AI, we usually see like all the some cool POCs or some cool demos. That's it, or some sales bits. But from an organizational point of view, to make data and AI successful, to make actually profit and revenue from it, there are certain stage you need to like take, and there are certain stage you need to follow. So I will mostly talk about those things today, and I will also give some examples from Azure point of view, like within Azure ecosystem, how you can get all of them with minimal steps. Um, so as I said already, my agenda is mostly enterprise data and AI architecture. I will talk about data and AI lifecycle a bit, how end-to-end data and AI platform works, how does it looks like, and what are the ideal data and AI components for any organization. And before I jump into the presentation, if I just give a small intro about myself, my name is Rahat Yasir. I work at Data and AI Platform Architect at CAE in Montreal, Canada. It's been more than 10 years I'm working in the data and AI domain. Worked at a lot of places, and yeah. And other than that, I'm a Microsoft MVP in artificial intelligence from last 7 years. So uh, trying to share my knowledge in data and AI industry, like a domain, as much as possible, so that a lot of people will move to this industry and empower more. So, okay, before we jump into the presentation and all the technical talks, we hear a lot of big buzz regarding data and AI. So a lot of people have also seen from the industry, they think it's just buzzword. If I be honest, like if it's a mix of both, there are some buzzwords and there are some opportunistic people who are getting opportunity, but also there are a lot of like real work is also happening. So when we look at some numbers, by 2025, which is like 4 years down the road, AI market will be $60 billion. In 2016, it was just 1.4, which shows us how the AI market is growing, how exponential the growth is literally, and how it's gonna like grow more and more. So this is the right time, even if you haven't taken any AI strategy for your organization, this is the right time to take it. And AI can increase your business productivity by 40%. So it is. You can also ask me, is it applicable to all the businesses or just like a certain, just in the to technology industry? No, actually, it's actually applicable to all the businesses, because through data and AI, you can offer new services. You can get a competitive edge from your competitors. You can find out how to keep your customers engaged and have them within your organizational boundaries, so that you can have more revenue, more clients, more features, and it's going to continue and continue, because instead of like taking regular business driven or feature centric decision, your decisions will be more like data driven and data centric. And the third one I would like to mention is the COVID situation, which started 1.5 years ago. We all know that, and most of the industries are badly impacted because of COVID. But one of the thing we have noticed that because of COVID, AI and data industry has got more encouragement, more funding, more opportunities, because we got the realization, okay, we need more automation. We need to be more data driven, data centric. All those numbers we see regarding COVID, the growth and everything. So those are actually the blessing of data science and AI. So, okay, it is important. We have the idea. Now, from an organizational point of view, if you are thinking, okay, how can we like invest our money in data and AI so that it's not wasted. It's actually going to give us like a return on proper return on investment through some like ways. So it is not just like creating collecting some data and collecting developing some POCs and putting it in production. No, like for just some testing POCs, like a proof of concept, it is okay. For MVPs, it's fine. But when you are thinking about like making like your organization data driven or data centric and take AI driven decisions, it needs to be you need to have proper strategy. And the strategy, I will just like share a couple of slides regarding how the strategy works. So first, you need to have, we see it a combination of three different domains segment. One is data. You need to have, you need to collect all the data sources. You need to have proper data lake, proper data ingestion. You need to bring the data from public source, private source, from different systems. You need to have the different kind of like strategies of cold and hot storage. You even need to do a lot of data processing as well, because not all data has the value. You need to find out the KPIs from those data. Can I get something from this data or not? Okay, this is the first one, which is like on the left side, the data. Then you have the knowledge and skill on the right side, which is you need people who has like data science like knowledge. You need to have analytical capability. You need to empower your organization with different kind of like dashboard and visualization, which is a representation of all the data driven decisions, all the patterns or all the information will be showed here so that your executives can take the decision. So that is the knowledge and skill you need. And the third one, which is in the bottom, is the information context. You need a platform where your like skilled people can work with the data, interact with the data, design those AI models, and put them in the market or like in the production. You need to do all the information management. You need to do design information architecture, data flow, and at the same time, the most important part is you need to implement information security and governance as well. So with the combination of all the data, knowledge, and skill and information context, you will see you will have more understanding about the how the organizational data is today, how the priorities are. You will be able to like set up the data culture, data centric and decision making through governance, and also the identify the ROI and business driven priority. So all of them together, you will have AI and data centric planning as a strategy. So like to be solid, to be like proper like roadmap, this kind of like strategy is extremely important. Otherwise you will find yourself completely scattered in different corners. So when we talk about an organizational point of view, the enterprise data and AI, so it is not like we just collect the data, have POC, your organization is data driven or data centric or AI driven. No, there are certain maturity level. We call it like we follow this kind of like triangle diagrams where to maximize your return on investment, you need to follow in data and AI. You need to follow this process. So there are like 5 steps. The first one is collecting all the data, bringing different data sources, because yes, data is the oil, but right, you need the right data as well. You can't just like bring random data and expect that your KPIs will be fulfilled. So you need to collect data. You need to have proper platform for that one. Then once you have the data, you need to find out information from the data. Data is nothing but the information from the data, all the KPIs, data insight are the actual key for your business. So from the data, you will have information. It means you need to dig more. You need to find different patterns. Once you have the information, while you're doing that one, you need to set up your organizational data management, data governance, and also how can you generate revenue from data and AI? Because you have the data, you have invested some money, you have done some AI POCs, but it is not exactly production driven or completely ready to be a standalone feature. So you will get all the knowledge from in this side. Okay, what are the things you can do, what are the things you cannot do, how to automate all those steps so that you are spending less manual work, and all those things are properly uh, like following through data ops and ML ops process. Once you gain all the knowledge from your data and ready to generate the revenue, then you will notice that okay, you did a lot of mistake. So that's where the interesting part starts. You will have the understanding, okay, sometime we have seen in the like from the organization that people have invested $10, but the return on investment is $5. So it is not something justifiable. So you will have those understanding, reiterate based on the learning, ROI and experience, so that you have the knowledge, and you will reiterate based on your okay, I did those mistakes, we need to avoid that, we need to redo all those things or few things. And based on those fixing, you will get into that insight stage, which is actually applying learning and understanding for your organization, and make data driven decision, AI driven decision throughout the organization. So this is the process. Like it's not just capture the data, do some POCs, your organization is ready. No, there needs to be certain amount of steps to gain the complete maturity. So these are the, we call it data centric and AI driven organizational triangle. So when we talk about enterprise data and AI components, so what are the components that you need? So we have divided those components into three different section. One is data component, one is AI component, one is platform component. From the data component, you need to keep ingest data. You need to have all the data pipelines. You need to maintain hot storage, cold storage, have proper disaster recovery, backup strategy, all those things. And then, as I said, not all data has the value. You need to do your data transformation. After doing the data transformation, a lot of times you need to do data reporting and visualization. Some suppose to see your stock price, how your organization is doing, how is the sales numbers are looking. You can represent different kind of dashboard of those data. Then the data consumption. Sometimes the data that you have ingested and stored will be used in different kind of applications or systems. So you need to create a data consumption process so that it's properly, the data flow is properly managed. You need to manage metadata as well, because metadata will help you for data management and data governance. Who has access to the data? Because for data privacy, we need to follow certain amount of GDPR, ER99, those kind of rules, and metadata management will help you with that one. You also need to do data exploration. As we can we are not in most of the cases are allowed to download the data in our local machine, or get access to those data lakes and data warehouse. So you need to have some kind of sandbox environment where people can get do their data exploration. Data will be democratized, and throughout the organization, everyone will have access to the data to do data driven discoveries. And all those pipelines, all those boxes will be automatically connected to each other using following data ops and automation. And while you're doing that, you also need to do data quality check. So these are the data components that you need to have from an enterprise point of view to be mature for completely data driven organization. Now from the AI components, whichever platform you choose, what are the components? So there are certain cases where you won't have any enough data. So in that case, are you gonna do simulation of every single data, or develop all the models from scratch? No. Whichever platform you use, Azure, AWS, GCP, or combination of everything, they need to provide you support you certain amount of predefined AI use cases or AI models. That's the support that you get for the common cases like OCR or facial recognition or speech to text. So that kind of common business need, your platform should give you that support. Then as you will design a lot of custom AI model for your organization, your platform needs to have support for custom AI model hosting, training, development. So that's the custom AI modeling with all the frameworks that we are using today. Then the AI model hosting. Your model, your platform should give you the support for batch processing, real-time processing, that kind of a model hosting process with scalable, sustainable features as well. AI model, one AI model is not just like the life cycle doesn't end right after putting it into the production. The it's kind of like you need to complete the AI loop by continue your AI model process by putting it into production, monitoring that one, and if you need to retrain that one. So if your like platform give that support, that will be amazing. Otherwise, you will have to do a lot of custom development to build that side. And the moment you realize that your data is drifting, your model is not performing as you were expecting, you will have to retrain your model. And one of the key thing in AI component in an enterprise point of view to keep the cost low, your AI computation. So when we do all the like data discoveries and AI modeling, you need a lot of computational power. So if you need to move the data from different places, your computation is not close to the data. In that case, you need to do a lot of like replica of the data set, and which is gonna be costly. And also getting using those GPUs for hours or hours for different data discoveries and AI discoveries, it is also expensive. So for that one, your computational support is extremely important. And outside of that, all those like boxes are completely connected with each other through ML operations activities or different kind of like robotic process automation or AI automation. So within those like automated approach, all the features, it will give you a full package of AI components that your enterprise needs, not just couple of like POCs or couple of use cases. To cover all the use cases, you need more than that. And the last one is platform components. So which is a kind of like combination of both of them. So which means you need to have proper data governance and management strategy. And a lot of times you do it with different tools. Suppose Azure, if we talk about Azure has a tool called Azure Purview that can give you that kind of like opportunity. Sometimes it depends on your organizational need. If you're within your, if you're working in a big organization and you have multiple like cloud used throughout the organization, you need to have multi-cloud data platform or a multi-cloud support. So in that case, there is a new term called data mesh that is getting very popular because of this multi-cloud platform support, where you are connecting multiple like data lake from different cloud organizations. But again, this could be a bit challenging and costly to monitor and maintain. So you just need to do a bit more careful when you're designing it. And again, before just jumping into the product or AI, cool AI research, you need to do decide business-driven return on investment. So what are you investing and what kind of like return you will get? Because there are like lots of components here. While you are doing that, you also need to ensure the data security, ethics, bias, and through different governance. And this will actually help you for data-driven decision making. And again, you cannot achieve it in one day or in one quarter. You need to have proper short-term and long-term strategy so that the team that you're going to hire, they will be enabled to do certain amount of stuff while you're supporting all the other things. So that is enterprise data and AI component. That's how it looks like, with all the data components, AI components, and platform components. So we will go a bit details in data and AI side and what are the key personas are involved and how the life cycle looks like in next 20 minutes. So now the data platform and the life cycle. So the first thing that we see, this is the data ingestion life cycle and key personas that we see from an enterprise point of view. So there are like 6 different steps. One is set goals, review, creating pipeline to ingest the data, data report and visualization, data quality review, KPI, and insight. So there are like certain amount of like roles that are involved in this like life cycle. First one is business leadership. They are the one, BAs or leadership are the one who sets the goal. What kind of data we want to ingest. Then the data architect, they are involved in the process to review the data source and how the data will be ingested and stored. Then the data engineer follows the lead of the data architect to create the data pipeline to bring the data. The data could be in a server or a file storage or API or some kind of like batch ingestion or SQL. So the data engineer's job will be to bring it. Then the data modeler. So when you bring the data, you need to do certain amount of like data modeling. If you are doing like some kind of like a reporting, so you need to modify the data sometime in certain amount. So data modeler is the one who is going to modify the data, create some kind of data reporting and visualization for the BI and organization. And while we are doing it, data engineer is also responsible to like identify the quality, check the KPIs, review whether what is the amount of like missing data, missing components within the data, how many corrupted columns, rows, or other stuffs are there within the data. And we have the data visualization, sometimes completely separate. They involve in this side, and data analysts and data scientists who are involved from the data modeling right after we ingest the data till the end of the cycle, because they're the one, they need the raw data untouched, and also they sometimes need the curated data which is already refined after applied after some hard rules and like soft rules. So data analysts and scientists are the one who will find out different kind of like values, extract meanings from this data, and also design different kind of like patterns or sometimes algorithms from those data. So this is how the data ingestion lifecycle looks like, from ingest like setting up the goals to storing it into ingesting it, creating architecture, storing the data, doing analysis of the data, creating reporting visualization of the data, and then like getting the actual result from the data. So if we like talk about what are the components within this like life cycle, we saw ingestion, storing, transformation, reporting, and consumption, and at the end, data governance, management, and data exploration. So, okay, if we see it in a bit detail, then what are the things we can. So when we see it in a proper diagram, then we see it like that. So in the ingestion section, we are ingesting the data. Sometimes we are doing data migration from on-prem to cloud, or we do a real-time ingestion, or we create trigger and pipeline. For the right after the ingesting the data, we have data store, where sometimes the data is structured, unstructured. If it is unstructured, it's files. If it is structured, it's SQL tables or something like that. We are also like needs to set up like, okay, data will be in the hot storage. If the data is already in the hot storage from last 1 to 2 years, we can put it in the cold storage as an archive data. We also need to put the data in different zones. Sometimes we have like raw zone, bronze zone, silver zone, gold zone. So the data we just like ingest will be is always in the bronze zone or raw zone or bronze zone. Then we apply some hard rules from the organization, then put it in the silver zone, and then we apply like business rules and put it in the uh, gold zone. We also need to ensure the data security. Who will have access to that data? We may need to do some kind of like data masking as well in this process. Then once we have the data, we export the data for data processing and visualization. Sometime for data science steps, we do some kind of data wrangling, do some kind of like data like computation, because and also create some kind of like data wrangling or data transformation recipes as well. And the last part is data serve and enrich, because you have the data. Now you need to do something with the data. You can share it between different like systems. You can create like put it into a consumption zone so that Power BI based reporting or BI based reporting or other systems can talk to it. And underneath we have data monitoring, like if like the data is called quality is good or not. The alerting, if pipeline fails, we need to monitor that. Administration, what kind of data is that, whether which zone it is coming from, which zone we are storing it in, all those things. While we do the data governance and access management, and it will be in a complete cloud platform. And all those things we are doing actually with the help of data operations and ML operations. We are also using BI and analytics to find out different patterns. We are using data sandbox for data exploration and actually using the data for discoveries. We can also have data marketplace, as if we ingest 20 types of data, you to get the full view of the data. And also we can also have different kind of ML use cases. So if we look at the Azure platform, so can we get all those components that an enterprise need? It's just an example. Yes, we can. We can see all the streaming data on the left. Then we have unstructured data, semi-structured data, relational data, and different kind of like data services. And we can see all those streaming data could be ingested to Event Hub or Azure IoT Service hubs, where in the process we will get Azure Stream Analytics to use the data to store it in our data lake Gen 2, or apply some kind of like Azure machine learning or cognitive service based approaches, or even do it real time Power BI or that kind of dashboarding. If it is unstructured data or semi-structured data, we can use Azure Synapse Analytics. If you haven't used it, you can try this tool, where this has the data ingestion, data storing, data warehouse capability, data analytics. All those like individual things are already packaged, combined within this Synapse Analytics. You can try that one, where it will help you with all the pipelines, triggers, whether it's batch processing or like some kind of like schedule to bring the data, whether it's unstructured or relational but structured, store the data in your data lake, or expose it to data warehouse after doing certain amount of data transformation using Spark pool, or even like T-SQL or SQL pool. And you can also like put serve the data through Cosmos. From there you can also share the data for within different applications and analytics, and you can also have different reporting. For discovery and governance, you have Power BI, and underneath you have all those secret key vault management, Azure AD, cost management, and everything. So it is giving us a end-to-end like a platform system to get all the things we need from an enterprise point of view. Then now let's talk a bit about AI side. So we got to know that in within the data we have a certain amount of things we need to follow: data ingestion, storing, data transformation, sandbox, and everything. From the AI, what are the things we need? Plus, also when we talk about here about AI, we hear, okay, is it just AI or machine learning, deep learning, data science? Some people gets confused as it's a more business topic. So I'm giving a small overview. So in terms of artificial intelligence, the entire like a domain we call it AI, but machine learning is a subdomain of AI, and deep learning is a subdomain of machine learning, and data science is actually overlapping all those like domains, because data science is empowering deep learning. We may have to do a lot of data science activities or data processing activities before applying deep learning, or even machine learning, or even which is AI based application development. So then we can see like that's how it is actually designed. It's not like the same thing for like all of them. When we talk about like data and AI, there are like two of the new concept that has emerged recently. One is data ops and ML ops. Some of us are actually like familiar with DevOps, which is when we design application, and within the application software development lifecycle, we have the DevOps role, who does CI/CD, ensure collaboration between different teams. They are the one who are responsible for quick development, production, deployment, hosting, maintenance of the infrastructure. But again, like when we talk about not application, just the same thing with data and AI. We call it data ops for data, and AI or ML ops for AI lifecycle. So it's the same thing of DevOps for data and AI. So data ops ensures automated process oriented methodology used by analytics and data teams to improve data quality, automated data ingestion, automated data processing, and to reduce the time cycle, life cycle, and prepare the data as soon as possible. So all those automation is actually the responsibility of data ops. And when we talk about ML ops, they're the one who are ensuring deployment, monitoring, reproducibility, scalable, machine learning, and also like following the CI/CD pipeline, which is continuous training. You're continuously training, continuously integrating with the different pipelines, and continuously development, so that the model that you have trained could be in production right away, and your model is always up and running with the new set of like data or a new model. So this is kind of like the that was the high level, but again, like AI has its own life cycle as well with key personas. So when we talk about that one, AI by itself does is not bringing any value. AI needs to empower different kind of like mobile, web, or client-based application to find out actual like to empower users or find out actual use cases of those AI models. So for that one, we need to first business leadership set the goals. Once they set the goals, they data engineers help to gather data to train the model, because to create the AI model, you need data. So once you have the data by the data engineer, data scientists are the one who use that data, develop the ML model. So in this phase, and with your data scientists, there are ML engineers, machine learning engineers who works side by side to create all the pipelines of ML ops, take the model whenever it is ready to put it in, suppose ACI container or AKS for the deployment into Kubernetes service for a scalable AI model deployment, and creating APIs for those AI models to connect it with the mobile apps or web apps or different kind of inferencing, where app developers also get involved, and they communicate, work with the ML engineers to get the API, ensure that connection is working with the ML like mobile app or like web app or those client facing application, and it's following the proper process. And again, data scientists are involved at the end for model monitoring, model management, whether the result that your model is generating, it's valid or not, whether it's giving good info, like it's generating garbage or not. If you feel that okay, the model is not generating good result anymore, you may have to like retrain the model. So that's where data scientists and ML engineers rewrite new pipelines to retrain the model, find out data drift, find out those model monitoring stuff. So that's how the AI and ML lifecycle looks like, from ingesting the setting up the goals, ingesting the data, developing the model, packaging the model for deployment, and connecting it with the like different applications through APIs, and then monitoring them. So that's how the end-to-end lifecycle looks in this case. So from a business point of view, if you are like it, as we have like 10-15 minutes, so maybe I'll go to the next one. So if from a business point of view, if you ask, okay, so what are the steps we follow to actually develop the model? So the first part of developing model is the database. So you need to have proper data storage. You need to ingest the data, which is the first part. Then you will spend 50% of the time like for data preparation, where you will do data wrangling, data transformation, data validation, data featureization. Um, so you can also ask, okay, if my data is already in a proper tabular format, and I'm just ingesting it, why do I need to transform the data, validate the data, or featureize the data? Suppose you are designing an AI model based on insurance price prediction example. So in that one, you have your customer information, and on that, one of the column that you have is date of birth. But date of birth has nothing to do to predict the insurance premium of this individual customer. They need date of birth could be an like a very big range of like numbers. What you can do is to make it more consumable by the model, you will have to convert the date of birth into a date or like into an age. So it's 50 years old, 20 years old, 25 years old, so that you can do different kind of like bucketing or encoding of your like columns, and the model can easily consume that one, use it for like further processing. So how the transformation works, so your like you will, when you load the data of age, like date of birth, if it is in the string format, you are converting from string to date time, and then you are subtracting today's date from the date time, like of this age, like date of birth, and then you're getting the age, and then ages could be some kind of like integer. It could, you can also like use it, do some kind of like encoding to do that kind of like bucketing. So all those like individual steps are actually following within the data transformation and data wrangling, so that your model is more like can consume the data easily to find out different patterns. And in with throughout this process, there could be some situation where you have missing data or like corrupted data. So you will also like have to like impute different kind of like average, mean, max, to keep all the data instead of like keeping missing data. Once you process the data, then you get into the model building and training process, where again, like which algorithm you will use. So suppose when you are using like it depends on the type of the model you are developing. When you are predicting the insurance premium, you are predicting a number. So it's a regressional model. So if you were the one were deciding something else like classification, then it would have been like within the two or three classes, that would have been classification. If you are predicting something regarding time series, based on the time and prediction, that would have been time series model. So as here, you are selecting the domain as regression, and then you will see within the regression there are like lots of algorithms are there. So XGBoost, there are like light GBM or CAD boost or different kind of like logistic regression. So which specific regression model you will use for that one? So there are two types of approaches. One is if you know already which model to use, you will use it. Or there are tools like automated machine learning, where all the models are there. You will just select the hyperparameter, and it will automatically run and tell you, hey, for this data set, this is the best model, this is the best accuracy we can get, you need to use it. So you can also like go with that kind of approach. Once you get your model, you will have to test it. You will have to validate that your model is not giving garbage values. It is giving like proper values. You will have to mix it with the validation set, and then you will deploy it. So how the deployment looks like. So once you get the model, you will have to containerize that one. You will have to put it into an API and expose the API to a web or mobile app, so that the API based communication can happen. And also, once you are using the model, you need to monitor it. It's doing good result, bad result, how like sometime when we design the model, we also like find out the top impactful like features for this model. So if we have used 20 columns, we have the 5 columns as the top impactful. Okay, and we also like store the how the data distribution of those 5 feature is, or how the skew looks like. And then with the new data in the production, we take the data point and try to put it into that data skew of the training data to see it's within the skew or it's drifting from the actual training data or not. If you find out over the time the skew is drifting, the mean is drifting, then you can tell, okay, the model is started to like perform bad. You need to like retrain the model with the new data. So there are different ways of doing it. And again, if you find out no, it's not doing the right thing, you'll have to go back and like follow the process again and again. So when we like talk about like after doing the data modeling, when we talk about a platform components, uh, what are the things you need, your data scientists or AI developers need? So again, the first thing is your data scientists will need pre-trained like AI models or common use cases, because you cannot create model of every single use cases. Sometime you will use pre-trained, like those speech to text to speech, or like anomaly detection, or like facial recognition, those. But again, there will be a situation where you will design custom AI modeling, where your data scientists will use Jupyter Notebook or AutoML tools, or ML Designer, or AI virtual machine, where everything is installed. There's CPU, GPU, computational capability. So your platform needs to support your AI developers or ML engineers with those specific tools to make them more efficient. And also, when you're doing the training plus inferencing, creating the production results or prediction, we call it inferencing, you need to be able to create compute cluster, whether it's like for dev environment, single container, for production environment, scalable Kubernetes cluster. Your platform should give you all those like benefits. Otherwise, you will spend a lot of money of doing a lot of like manual work and manual plumbing. And during the training phase, a lot of times for custom training, we do annotation, data annotation. Sometimes there are like third-party tools that you can use for data annotation, or sometimes some of the AI applications or AI platform gives you that kind of annotation tool as well. If you get it from your platform, that's great. And at the end, you need to have MLOps, which will give you continuous training, model testing, model monitoring, drifting, deployment dashboard, all those capabilities. Because you need to know, uh, like developing a platform, it should not be your headache to get data-driven results and data-driven use cases. You need to use a platform that has already all those capabilities. You will just onboard into that platform and use those features to get business-centric or business-driven benefits and decisions. So if we talk about Azure or Microsoft AI platform, they have like actually all of them. They have the AI services, which is pre-built AI with cognitive services. If you haven't seen it, you can should take a look. If you want to do chatbot, there is bot framework where you can easily create a knowledge base of all the frequent asked question that we see in a bot, and then create a Q&A maker and connect those two. Voila, your AI like a chatbot will be ready in an hour, and it's that easy to build. Your custom AI, there is Azure Machine Learning platform that gives you all the Jupyter Notebook, AutoML, the computation, and everything. Then for AI tools, coding and management, you have ML Workbench with all the Azure notebooks, Jupyter notebooks, your ML Studio for designer, your VS tool for AI and ML, and it supports all the new deep learning frameworks like TensorFlow, Cafe, or even PyTorch. And for the AI infrastructure, you will need for the data lake, SQL Server, Cosmos DB to store production data. You have all those support. And for AI compute, you will need the Spark, Data Science VM, Batch AI, AKS, ACI, or IoT Hub. You have them as well. So now, if you ask like how a production side looks like for model production and monitoring, so the moment you have your AI code ready, you do your data sanity test with the data, you do your unit test of the data, then you create your machine learning workspace, create your machine learning compute, and then machine learning pipeline. So all of them are within Azure ML. It's all those steps are actually like a model code or model development steps. So once you do it, you publish the machine learning pipeline and you can train the model. You can evaluate the model on the right. You can even, once you evaluate the model and you are comfortable, you will register the model in container registry or AML model management so that I have registered the model. I want to test it. You can package the model as a container image. You can deploy the model as a web service, as we said, as an API using Azure Container Instance. And also, if you can test the model through a web service. And once you are confirmed that, okay, this is the model that I will put in production, you can easily deploy the model in a scalable manner using Azure Kubernetes Service. And it is also a web service. And all those things are actually automated following Azure pipelines. And even you can also use App Insight to like see how many people are using the model, have all the triggers, have data-driven, schedule-driven, metric-driven approach. So the entire production platform is actually designed for you. And from an end-to-end approach, if you want to start something small within those like Azure ecosystem, you can have your data lake or data warehouse where all the data is residing. You can just like data factory breaks for all the data transformation. You can connect them with the cognitive service and machine learning for model development. Once you have the model, you will register it on the container registry, or you can deploy the model in ACI or AKS so that your model is serving different web and mobile and APIs. And all the new results, you will store them in Cosmos DB. And you can also have all the reporting and automation using Azure pipeline. You can have Power Apps and Power Automate based BI analytics, data dashboard, ML operational dashboard, and business dashboard. So that's with some small approaches, you can create single pipeline, and that could be used in many operations. So that's it about my presentation. It's almost 46 minutes. Thank you for attending it. If you have any question, you can reach me in LinkedIn, and you can ask me with message. Or even if you have any question, you can ask me here. And I hope you enjoyed it. It was useful, and thank you.